Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to explain what the Pythagorean Theorem is and work through example problems where we need to find the missing side of a triangle when two sides of a triangle are known or given. The Pythagorean Theorem is a geometric principle that relates the lengths of the sides of a right triangle. This theorem can best be understood by looking at this diagram of a right triangle. A right triangle has two legs and a hypotenuse. Let's go ahead and label these. We'll label the leg on the right as A, the leg on the bottom as B, and we'll label the hypotenuse C. So let's go ahead and let's write that down on the right-hand side. So A and B are the legs. C is the hypotenuse. And we're making the assumption that A, B, and C are all greater than 0. Extending out from each side of the triangle is a square. Let's fill in the area for each of those squares. So for the one on the right, the side lengths are A, so the area of the square is one side times the other side. So this area is A squared. For the triangle on the bottom, the area is going to be B squared. And for the triangle off of the hypotenuse, that area is going to be C times C, which gives us C squared. The area of the square on the hypotenuse, that means C squared, is equal to the sum of the areas of the squares on the other two sides. And we can write that algebraically like this. We would say that A squared, the area of one side, plus the area of the other side is equal to the area of the square off of the hypotenuse. This relationship is used a lot in mathematics and scientific applications, and it's really good idea to go ahead and memorize that formula. Let's now use the Pythagorean theorem to find a missing side of a triangle. We often only know two sides of a right triangle, and we need to find the third side. In these examples, we're going to be asked to find the missing side of the triangle. The first thing that we need to do is label the unknown side. Before we begin, let's go ahead and let's write a triangle and let's label all three sides, and we can refer to that when we have to label one of the unknown sides. So our right-hand side is A, our bottom side is B, and our hypotenuse is C. So in this first example, our unknown side is at the bottom, so let's label that as B. You could choose any letter, but it's nice to be consistent. So we'll begin by writing down the Pythagorean theorem, where the square of one leg plus the square of the other leg is equal to the square of the hypotenuse. Now we're going to fill in the values that we know. So our A is 4, so A squared is 4 squared, plus B squared, that's our unknown, is equal to our hypotenuse squared, and that's 5, so that's 5 squared. So this gives us 16 plus B squared is equal to 25. We need to solve for B squared, so we'll subtract 16 from both sides of the equation. So we have B squared is 25 minus 16, which is 9. And then we're going to take the square root, and we're going to remember that B is positive, so we're only looking for the positive square root. So B is equal to 3. And on our right-hand side, let's go ahead and label the triangle that we just found. So we have a 3, 4, 5. So that is called a 3, 4, 5 triangle. Let's go ahead and complete our second example problem. So for this one, whoops, there we go. Now you can see the diagram up above. Our unknown is our hypotenuse, so we're going to call that C. And we'll begin with the Pythagorean Theorem again. So we have a squared plus b squared is equal to c squared. So our a is 1, our b is 1, and then our c squared is our unknown. So we have 1 plus 1, so on the left-hand side we have 2, and on the right-hand side we have c squared. We're now going to take the square root of both sides, so that we have square root of 2 is equal to c. And let's go ahead and let's label our triangle on the right. So this triangle we would call a 1, 1, root 2 triangle. I would encourage you to stop the video and see if you can complete examples 3 and 4 on your own, and then restart the video and see if you've done them correctly. For example 3, we're going to label our unknown side as A. We'll write down the Pythagorean Theorem. A squared plus b squared is equal to c squared. I always tell students, if you do enough example problems, you pretty much memorize the formula just by doing the example problems. So our a squared is our unknown. Our b is 5, so that gives us a 5 squared. And our c is 13, so that gives us 13 squared. So we have a squared plus 25. 13 times 13 is 169. And then we subtract 25 from both sides of the equation. So we have a squared is 169 minus 25. So a squared is 144. And if we take the square root of 144, we get 12. So let's go ahead and label that on our right-hand side. So this triangle was a 5, 12, 13 triangle. Our last example, the unknown is the hypotenuse. So we'll label that as C. Write down the Pythagorean Theorem. A squared plus b squared is equal to c squared. Our a is 7 squared. Our b is 6 squared. And our c is our unknown, so we'll write that as c squared. So 7 times 7 is 49. 6 times 6 is 36. And that's equal to c squared. We'll go ahead and add up those numbers on the left-hand side. So 49 plus 36, let's see, that's 85 is equal to c squared. And then we're going to take the square root of both sides. So we have the square root of 85 is equal to c. And I don't think we can reduce that easily because 5 goes into 85 17 times. So we'll go ahead and leave it as square root of 85. So for completeness, let's go ahead and label our right-hand side triangle. So we have 7, 6, square root of 85. The triangles that we found in examples 1, 2, and 3 are worth memorizing because those triangles appear a lot in applications and other courses such as calculus.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.